Hi everyone, welcome back. A little bit further, a little bit more crazy, but at the same time you're going to get them in tests at school. Let's look at some of the cases we've got here. Some of these terms might be able to be added together, and some of these might be able to be added together, some or subtracted. So let's have a look at which ones can. So using an 8, I'm looking for the squares. I'm looking for 4, 9, 16 and 25. A lot of people will look at that and know that you can write that as 4 times 2. Next one, looking for 9. How will I know to look for 9? Odd numbers with a 9. It's not going to be a 4, it's not going to be a 16. So that one's a root 9 and 3 9s are 27. Back to an even. 4 goes into that, so it's actually a 4 times tables. So that's a 4 times a root 5. Now the next one, 25 will go into it. So 25 will fit into it. How can I tell what gives it away? The 5s can often give it away as a 25. So let's have a look what that is. It's a 25 and it's a root 3. Let's tidy up and see what we've got. A root 4 is just a 2. So I can write, instead of that, I can write 2 root 2. So anywhere, anytime in maths, instead of a root 8, I can write a 2 root 2. It's really handy in later calculations. So this one here is a, instead of a root 9, I can just write a 3. Don't have to write the multiply, so that's a 3 root 3. A root 4, so that's a 2. Don't have to write the multiply, so that's a 2 root 5. And I look at the last one, and I've got root 25 is a 5, so that's a 5 root 3. So instead of root 27, I can write 3 root 3. Instead of root 20, I can write 2 root 5. Then I can look across these and say which ones are like terms. This has got root 2s, this one has root 3s, and this one has root 3s. So if I've got 3 root 3s and 5 root 3s, it's all together as 8 root 3s. Now remember, in the long run, it's talking about that's 3 lots of 1.732 and more decimals, but let's say approximately that. And this is 5 lots of 1.732. So all together you've got 8 lots of 1.732. I know it's crazy, but you know, those who are using them will see it everywhere. So we've dealt with this one, and this one, and we're left with a 2 root 5. One more example. I don't want it to become too long. We make it a bit more complicated by putting a number at the front here. So now I've got a 5 and I've got my factor tree. This is a multiple of 25. I'm looking for 25s in this case. So that's a root 25 times 2, root 2. So the 2 25s are 50. This one here is this one's going to be a 9. You start seeing the same numbers over and over again. So that's a root 9 by a root 3. Some of you could just do the number in your head. Hopefully you can. Once you get the hang of it, you can start to just look at it and know what it is. So this one's going to be a 25. So that's a root 25, and that's a root 3, because 3 25s are 75. And the last one, it's a 2, and it looks very long-winded. So that's a 9. You can see it's a multiple of 9. We're talking about multiples of the squares. So I probably should write that they are multiples of the squares. So that's a multiple of 5 squared. That's a multiple of 3 squared. That's a multiple of 5 squared. And that's a multiple of 3 squared. So let's have a look at what we've got. This is a 5 times another 5 times the square root of 2. This is a 4 times by a 3 times by a square root of 3. This is a 3. It's getting pretty crazy, but you'll see it in class. That's a 5 and that's a square root of 3. This is a 2 and this is a 3. Now a lot of you could have looked at that and just said, that's 5 5s are 25 root 2. But if you can't see it, there it is written in full. What I don't like about all of this is it starts to get very, I keep talking about the idea that it's very, very cluttered. And when things are cluttered, people make more silly mistakes. So let's go back to this one. 5 5s are 25 root 2. 3 4s are 12 root 3. 5 3s are 15 root 3. 3 2s are 6 root 2. Now I can collect my like terms. So I've got root 2 can be subtracted with the root 2. So 25 root 2, take 6 root 2 is 19 root 2s. And you could check it with your calculator with decimals. 12 root 3 plus 15 root 3 is 27 root 3. Now you can't go further. People will do, especially when they're not confident with it, they'll go stupid and do all sorts of crazy things like root 2 plus root 3 is root 6. That doesn't work. You pick up your calculator and see that it doesn't work. So there we go. That's probably as far as I want to go with collecting like terms. If you find you get helpful, please just let your friends know.